recording. Wait, why is it? Oh yeah, okay. Whoops, where'd it go? I had it already. I'm big. Ready to go.
Transformations in geometry. Basically what they are is changing an original size, shape, or position of a figure to create a new image. So you're going to start with something and you're going to change it in some way and end up with a new image. Now there's 4 types of transformations. The first type is a dilation. And dilation is taking a figure and either enlarging it or making it smaller and reducing it. But you're going to keep the dimensions, those ratios, the same. So you're going to create similar figures. The second type, rotations. So you're going to start with a figure and then picking a point and an amount, you're going to rotate that figure. So you're not going to change its size or its shape. The next type is a translation, or sliding it. So basically you're going to have a figure and you're going to slide it in some direction. And the last type of transformation is a reflection, or flipping it. So with a reflection, you're going to need a line that you're reflecting. So notice, here I reflected this triangle over this dotted line. Certain transformations are more specifically described, and we call those isometries. An isometry is a transformation where the original shape and new image are congruent. Another way of saying this is to call it a rigid transformation. Not rigid, but rigid transformation. So only 3 transformations are isometries. Rotations, I'm going to write an I, are isometries. Translations are isometries. And reflections. The reason why dilations are not isometries is because you're changing the size of the shape. So these two are never going to be congruent when you have a dilation, unless your scale factor is equal to 1. How do we describe translations? Well, we're going to use an arrow to show the original image going to our new image. So if you just made one transformation, you would write this as triangle ABC maps onto triangle A', B', C'. And I've written that down below. So those little apostrophes actually mean prime. Let's say you did another transformation. Then that would become triangle A', B', C'. So every time you go through a transformation, you're going to have one more prime on each of your vertices. So keeping this in mind, you can perform any type of transformation.
Okay, I have one more video to show you that explains it just a little tiny bit more, and I hope there was nothing bad on that. Okay.
In section 7.3, we are going to look at isometry transformations. Isometry means fixed. A fixed transformation, every pre-image will be congruent to the image. The first isometry transformation is a translation. In a translation, we're going to start with a shape. And we're going to translate that shape to a different position without changing that shape's orientation or flipping that shape. The place where we started is known as the pre-image, and the image where we end up is called the image. Now you might have been told that this move was called a slide. The mathematical term for a slide is a translation. Make sure you remember this move as a translation. The second isometry transformation is a reflection. In a reflection, we start with a pre-image, and we're going to reflect it over a line. So we're going to need a line of reflection. So if I reflect this pre-image over this line of reflection, I end up with an image that looks like this. Now be careful. A reflection can look like a rotation depending on the line of reflection. If I have a line of reflection that looks like this, when I flip this pre-image over the line of reflection, I end up with an image that looks like this. Now this looks like it should be a rotation, but if you look, these two are reflections of each other. You might have been taught that a reflection is a flip, but the mathematical term for a flip is a reflection. In a rotation, we're going to start with a pre-image. And we need to have a point of rotation. And then we're going to need to know how many degrees and in which direction to rotate this image. So if I rotate in this direction, I'm rotating counterclockwise, and I'm rotating 90 degrees. So if I rotate this image 90 degrees counterclockwise, my image will end up being a sideways heart.
And that's all we're going to see because the rest we're not covering.
Notice that a 90-degree counterclockwise rotation
Keep going.
is the same as a 270-degree clockwise rotation. If I take that same pre-image and pick a point of rotation, and then this time rotate it 180 degrees clockwise, I end up with a heart that is upside down right here. Notice that a 180-degree clockwise rotation is the same as a 180-degree counterclockwise rotation.
Okay, and that's where we're ending that.
A glide reflection